Welcome. This video comes as the first installment of the 3 parts in which I'll cover the second chapter of HCIA Datacom version 1.0, Network Reference Model. As I mentioned earlier in the introduction to this chapter, I'll be breaking down this chapter into 3 separate videos. This particular one will cover the first part of this chapter, Applications and Data. The data always is generated by different applications, such as HTTP, FTP, DHCP, TFTP, SSH, and other applications. These applications generate the data and needs to be transmitted to the end on which it's going to be used. The generation process and transmission process does not need to be completed by the same device that generates the data. It needs to be transmitted in a completely different kind of format in most cases. And that's where our role comes in. But in this particular part of this coverage, we are going to look at the applications and how these applications come up with the data. The applications are really the origin of the story. Applications are normally used to meet various requirements of people. For example, you need to access a web page, and so you design HTTP. You need to do online gaming, online video playback, so you create applications for each of those. Information is normally going to be generated every time those applications are used. When you send a GET request to a web server, there is information that's going to be generated. This information can be in form of text or pictures or even videos, but all these are just ways of presenting information. So with all the different applications you're using over the network, there's several kinds of information that are going to be generated. It could be text information, it could be image information, it could be sound information, it could be 3D, it could be virtual reality information, it could even be video information. Irrespective of which information is generated, at least we know that application implementation is through data. We know that the application generates data, and this data needs to be moved to somewhere the user can see this data. So there are 2 main things we need to understand here. First is data generation. And in the computer field, when we talk about data, we simply mean a carrier for all kinds of information. We just talked about text, we talked about video, we talked about image, we talked about audio, we talked about all these are kinds of information. They are all carried as data along our network. And then we have data transmission. Now, note this, we just mentioned that applications generate the data. The important question we need to think about is, do you think it is applications that are also in charge of data transmission? I would like you to remember that computers can only identify digital data, zeros and ones. Computers are incapable of reading any other types of information. Therefore, when information is being transmitted, it needs to be translated into zeros and ones. On the other hand, on the user end, on the terminal, when the user is consuming this information, they do not have the capability of reading electronic data of zeros and ones. Therefore, this data needs to be converted to the information that needs to be understood by the people. As such, a network engineer needs to pay attention to what we call the end-to-end transmission process of the data. On the computer, on the application, it is data presentable as images. But we know that during transmission, it is data presented as zeros and ones. What exactly happens on this machine for this data to move from the image level all the way to the zeros and ones? That is the process we need to try to understand, because as network engineers, we need to pay attention to this end-to-end process, because at any time within the network, this data is going to be lost. At any time from the sending host, this data can be corrupted. How can we handle? How can we know what happened to what? in the process. We need to understand the end-to-end transmission of data. And this is exactly where the network reference model and standard protocols come in.